This is a 300 level session, so we assume certain WAF knowledge already. But if you don't, we're going to do a quick primer to talk about some of the WAF capabilities. My name is Kaustubh Phatak. I'm the Senior Product Manager for AWS WAF. I manage the bot mitigation and fraud prevention offerings within WAF.
And my name is Tzori Taman. I'm a Solution Architect Specialist for Edge Services, including CloudFront and WAF, which is a good thing because we'll be talking a lot about WAF today.
Awesome. So what do you expect from this session, right? So let me just build this slide. OK, so we are going to start with some of the emerging web threats that we see. So we'll start off with some of the bot mitigation, bot threats that we see, and then what's evolving with the advent of AI bots. We'll focus a little bit on what we see as AWS bot control and AWS WAF. We'll go into a little bit of the capabilities of the WAF. That's where we'll do a primer on the WAF features. We'll cover a little bit about the configuration and then jump into some real-world use cases. All right, so bot trends, right? So with automated traffic, we already know this. Like most of the automated traffic today is 47% across all traffic is bot traffic. And we have seen a slight uptick as well as downtick over month over month and quarter over quarter. And then what's changed in the past year and a half is the evolution and the sophistication of the attacks that we see with the advent of AI bots. The AI bots and the AI tools really just lower the bar for an attacker to carry out these attacks. So that's why we see more and more of these techniques being used. The other thing that has changed is the intentions of these bot crawlers, scrapers, scalpers, where they're not just concerned with getting the PII information anymore. They're looking at scraping all the information of your data to train the model and all of those things, right? A quick description of what bot is, right? Bot, for those who don't know, it's an automated software program that is designed to do certain action. That action can be good and bad. So there are few good bots like search engine optimization bots. We have bots that improve website performance, uptime, those sort of things. And then on the bad bot side, we have exploit vulnerabilities and in the online systems. That's typically what bots used to do 2 years ago. But now we are seeing a difference between scalping is becoming higher, scraping activity is increasing as well, and then account takeover activity is increasing as well. So really what we want to do is balance the pros and cons. So we still want to allow the good bots in and reduce the cons of allowing bots to access the websites. Now with AI, certain things have changed, right? Like now it's not just about these typical bot activity and good bots and bad bots. Now there are new risks that have shown up in the last year and a half. Some of it is like network attacks. There are automated softwares out there that make it really easy to carry out distributed denial of service attacks using residential proxies, mobile proxies, those sort of things. We also see an increase in SMS fraud, where we are seeing attackers use rotating phone numbers to trigger a lot of SMS fraud. Social engineering has now become easy, where you can write a really authentic-looking email, or even just any information. Propaganda campaigns are now easy, so that is increasing. There are certain things. If you're running AI-specific or LLM applications, then there are certain new threats like prompt injection, hallucination, data poisoning that have increased. And then because the whole AI and LLM system relies on the data, there's the data poisoning aspect that we need to look at as well. So now let's take a look at what we see from at AWS, right? Like we see a variety of AI bots ranging from GPT, ChatGPT, ByteDance, others, across all the customers, right? It's an aggregated view. We are also seeing like increase in the interactions that these bots are having with different URLs of the websites. And as you can see, like month over month, we are seeing like 155% increase from Q3 to Q4 in just the bot activity from these few bots. Now let's talk about, okay, the activity has increased. What are they targeting, right? So they're targeting things like news articles. So any sort of publishing that you're doing on the website, they'll get that information and then it'll be used for training so that the customer doesn't have to come to your website. So there's a ad revenue loss component there as well. They're also scraping product pages to get information about pricing. They're also about any sort of things that you have in the product description pages, reviews, those sort of things, to look at like how they can resell the tickets or even like sneakers and all of those things. Then we have user profiles being scraped as well. And this is an interesting one, which is fairly recent, where a lot of the AI bots or companies that are building these AI bots are building some sort of a user persona for individual users that are using these chatbots. So we're seeing a lot of user profiles being scraped as well to get like per PII, not PII, but like just demographic information that allows them to do better targeting and those sort of things. The other thing is we don't see a difference between the path that they are scraping. It's pretty much everything they can find, regardless of whether it's a document or an image or a CSS file. Typically, we have relied on robots.txt up to a certain extent to say, okay, what a bot can and cannot scrape. But what we see is hardly any bots are adhering to robots.txt. All of these bots are not even looking at robots.txt and just scraping whatever they can. So this brings in a change in dynamics, right? Like we cannot rely on robots.txt. We cannot rely on just blocking these bots because there are certain use cases where you would want AI bots to scrap your content because the whole search engine optimization thing will change as that information is being fed to AI bots. So we still want to allow certain information, and that's where we see the future direction going, is where we come up with some sort of scraping contracts where you say, okay, AI bot, you can scrape the content, but then you can scrape it at a certain frequency, at a certain URL, at a certain point of the day, week, those sort of things. So for that, there is visibility needed into all of that. Without that, it becomes really challenging to come up with any of these things, right? So that's the additional new thing that we have seen customers ask about is, okay, how do I understand what things are being scraped at what frequency, what time of the day, time of the week, etc. And then why is bot control and bot mitigation important, right? Like now it's even more important because if you're using any generative AI application for your in any of your workloads, $1 spent on bot control can save $277. Now that's a function of just the compute cost going up. Like traditional compute versus a Gen AI compute, there's a huge cost difference. So if you're able to weed out the bad traffic at the edge or before it gets to your high compute applications, you have a good story around cost saving. There's also a story about effective protection against threats and service degradation. So data theft, data integrity issues are starting to show up. We saw in the previous slide, like they don't really care about robots.txt. They don't really care about what parts of the website are being scraped. It's all over the place. So now that we need some sort of bot mitigation, and bot mitigation has to evolve so that we are able to address these new threats. That I'll call Zuri to give a quick primer on WAF, and we can go from there.
Thanks, Costa. So just a word of caution, WAF gets me super excited, so I even speak faster than I typically do. So I'll try and normalize the speed of my voice, but you'll see, I ramp up pretty fast. So this is here for all of you who are not super familiar with what WAF can do or forgot, just to set everybody to be on the same page. So what is AWS WAF? AWS WAF is a web application firewall. It deals with HTTP traffic. Only HTTP traffic. This is a web application firewall. It allows you to create rules or use managed rules in a very flexible way. I like to look at it in a way that you can treat it as a black box where you just turn it on and don't really think about what it does, and it does good things for you. Or you can really look under the hood and customize it fully, writing custom rules. And eventually, when we look at customers and what they're doing with AWS WAF, we find a good mix. So most customers will have a good mix of managed rules, be it our own AWS managed rules or partner managed rules, and a fair share of custom rules that fits their specific business logic, risk, and we'll talk a lot about custom rules as we go through the deck. Another thing that WAF provides you with is intelligent threat protection. Basically, it allows you to understand what you're dealing with in terms of who is speaking to your application. It's way more than just signature matching or counting requests. We can identify incoming bots. We can differentiate human from non-human actors. We can deal with fraud, specifically around your logging and sign-up processes. And we'll speak more about those in a bit. And as we dive into the different use cases, we'll be using these advanced rules in our config, as you will see in a few slides. And lastly, WAF provides you with visibility. I always say that if you cannot manage WAF, you don't have the manpower to manage enforcing or blocking WAF, it still has value if you turn it on because it provides so much visibility. Which requests are coming in, from where, at what rates, which URLs, when. There's so much data to be had by just enabling WAF logging, which in itself is a great value. Aside from that, and we'll speak about those metrics in a minute, it also sends metrics to CloudWatch, like all of our services pretty much, where we can see like a high-level count of which rules were hit, when, how many were blocked, how many were allowed, like high-level counts of the different behaviors all throughout the web ACL. Now, speaking of a web ACL is our construct. It's a basic construct that you apply to one of 7 reverse proxy services. I'll be using web ACL and WAF policies through this session. I mean the same thing when I use these 2 different terminologies, but the right name is a web ACL. So you basically create a web ACL, you attach it to one of these 7 reverse proxy services. Typically, we see customers use, primarily, we see customers use WAF with CloudFront, which is our CDN service, which packs a ton of protections on its own, even without WAF. And it's a good match for most of your web applications, or your ALB, or API Gateway, or any of the others. But the top 3 are typically the ones that we're seeing most used. And within those web ACLs that you attach, you start creating rules. Now, rules could be managed or unmanaged, or as we say, custom or customer rules. And all of the rules in the web ACL are processed serially in order. Each of these rules would have an action associated with it, so it can be set to specifically allow traffic in or specifically block traffic out. But when we determine that a certain request matched one of the rules, we stop processing the traffic. So we either allow it or block it. Meaning that any subsequent rules are not being processed. So the order of things does matter, and we'll see good examples for those as we go through the deck. Except for allowing and blocking, there are 3 other actions that are possible for each of the rules. The first is challenge. Challenge is a very useful tool you can apply to any of your rules and basically say, if a request matches a certain condition, I want to challenge it with a JavaScript. It's an interstitial JavaScript. We send it out, and we'll see the flow in a bit. And we can verify that we are indeed talking to a JavaScript-capable browser. If you want to ramp up your security, you can also enable the CAPTCHA action, which first triggers the same JavaScript, but then it actually forces the user to solve a CAPTCHA. You know, a grid CAPTCHA or any of the other 2 CAPTCHAs we have, verifying that we are dealing with a human. And you can, again, enable each of these actions on every one of your rules in the web ACL. And the last action is count. Count means that we don't really stop the request processing. We just flag that we matched a certain rule. If it matched, we write it in the logs, but we continue on processing the request through the rest of the web ACL. But we also, and this is a big thing, we'll talk about that more later, we can also label certain requests through a label, allowing it to go through the web ACL while we enrich it for other rules to ingest. And we'll talk about labels a bit later. So this is basically the construct, which is the web ACL. It's a lot, I know, but it is what it is. So to sum it up and zoom in into a specific rule, eventually a rule can either be managed or custom. Once you choose that, you need to set it as a regular rule. If you choose a custom rule, you should set it as a regular rule, basically meaning if we match, then do the action, or a rate-based rule, and we'll speak about rate-based rules in 2 slides, meaning that once we match, we start counting how many of these requests were matched. And only when we go over a certain threshold, only then we apply the action. So a rate-based rule is basically just the same as a regular rule, but we start acting only after a set amount of requests has gone through. Once we do that, we need to set the match criteria. So what do we look for in a specific rule? It could be a specific URI, user agent, header, any kind of part of the HTTP request. What would the action be? Again, allow, block, count, captcha, or challenge. We can choose to customize the request or the response. And this is a very powerful tool, especially when we talk about deception a bit later. So we can modify the request on its way in. If we allow it in, we can enrich it with headers for the underlying application to process and look at, basically using WAF as a signaling mechanism, like a downstream signaling mechanism towards the application. Or if we choose to block the request, we can customize the response that we send out. Typically, it would be a 403 forbidden, but we can customize it to anything you'd like, any error code, any content. So you can send a 200 OK, or you can send a 429 too many requests. You can do whatever you want with the response if you choose not to send it towards the application. And lastly, you choose what labels you want to emit. So what are labels? Labels are, I saw, maybe I clicked too soon. You were taking pictures? I'll stop messing with you. OK. So labels are, do it again? No, I'm kidding. So labels are metadata that we emit and attach to every single request that goes through WAF. Our managed rules do it by default. So whenever we match a request, even if we don't choose to block it, be it a SQL injection request or an IP reputation request or any of the managed rules that we offer, all of them attach labels. But more importantly, you can create your own labels through custom rules. So you can use whatever custom logic you have, whatever match criteria you have for requests. It could be something as simple as an IP is from a trusted list, or a request comes in from a specific country, or it could be as specific as a specific element in the JSON body matches a certain regex, or a combination of all of them. You can have and or not match criteria, and based on these, emit labels. Why are they so important? Because labels can be matched by other rules. So one of the match criteria we can have in a custom rule is has a label statement. So we can have some rules only paint, only highlight certain requests, emitting labels on them. And all of the subsequent rules in the WebACL, remember, they go in order, will be able to read those emitted labels and act upon it. So I can collect multiple points of data about a specific request by various rules and make a decision based on all of the knowledge I have on this request. So this will become super useful as we go through the different use cases in a few slides. So we mentioned rate-based rules. I want to do like a quick explanation of what rate-based rules are. So we mentioned it's basically a rule that counts how many requests of a specific match criteria occurred. We can go as low as 10 requests or as high as 2 billion requests before we do something. We can look at a time window of down to a minute or up to 10 minutes. So 1, 2, 5, and 10. These are new thresholds in case you didn't read the news. It's been out there for a few months. And that's the maximum window. So as soon as something happens, let's say we set the threshold at 1 million requests. But these million requests happened within 30 seconds. We perform the action after these 30 seconds. We won't wait for the 10 minutes. The time window is the maximum amount of time we will track these requests for. And we can aggregate requests based on multiple things. Now, the easiest thing to aggregate on is an IP-based, like aggregation key. So X requests from a specific IP addresses. So I'm aggregating by IP address, which all of your WebACLs should have. Like an IP-based rate limiting rule is, if it's the only thing you can manage, make sure you have it enabled in your WebACL. It's super effective. But you can have non-IP keys. We can match on method, on URI, on labels, and label namespaces. So again, it becomes super effective to use labels, and we can now start counting requests that were labeled a certain way. We can even set rate limiting rules that have no scope down. They just count the overall number of requests. Right, so these are all rate-based rules. You can have up to 10 rate-based rules in each WebACL, and I urge you to have at least 3 or 4 of them. They're super effective. To read more about them, and this is where you whip up your phones, 2 very good blogs. One is for basic rate limiting rules, like what are the 3 most important rate limiting rules you can put in your WebACLs. These are all IP-based rate limiting rules. And the second one on the left is more for advanced rate limiting rules. So what else can we start rate limiting on? Very useful reading for the flight back home over the weekend. We mentioned managed rules, and I want to dive into 3 managed rules that we have in AWS WAF because they will become important as we dive into the different use cases. So the first is bot control. Bot control is one of these advanced threat mitigation rules that we allow customers to enable on the WebACLs. And it basically does multiple things. It can operate in a common mode, which looks for the naive common bots, typically the ones that report themselves through their user agent, if there are like unwanted bot traffic, or we use it as well to verify good bots or wanted bots. So social media bots, SEO engines, GenAI bots. So we verify that the traffic we're seeing that is being reported by the user agent as coming from, let's say, a Google bot, to actually come from the address range that Google bots typically come from. So we also help verify that the bot traffic you are seeing is indeed coming from the correct sources. Why is it important? Because you can use common bot control to make sure, because we label everything now, that rate limiting rules don't apply to verified bots. Or conversely, apply 10 times more aggressively for verified bots, depending on your business use case. So all of these labels being emitted by common bot control, such as the category, whether it's a verified bot or not, what's the bot name, super useful in understanding. Even if you don't enforce anything, it provides you with a very clear map of how much of your traffic is driven by bots. And then the other mode to run bot control is targeted bot control. And by targeted, we mean bots that specifically target your application. Something more well-constructed, not just some script kiddie running a curl script in a loop. So these bots would know to act in a way that maybe avoids detection. And through targeted bot control, we start deploying active measures. So we start challenging incoming requests. We start keeping track of the device fingerprint. We make sure to only allow sessions, not IPs, sessions that stick to the same basic rules of a normal human being. So if we build a machine learning model that allows us to understand what is a typical user flow out of the many user flows you have in your application, and anything that looks different from that, we flag it or block it. We allow tracking of if a specific token is being reused across multiple IPs or multiple AS numbers or multiple geographies. So we know to track anomalies through targeted bot control, and that's the more advanced use for bot control. So we'll be talking about bot control more in the use cases. I'd like to move on to the second managed rule that we want to cover today, and that's ATP. So ATP is one of 2 fraud protection rules. Account takeover prevention deals with your login process. So this rule, again, managed rule, allows you to configure your login page, and it only looks at login traffic, not at the overall traffic to the website or the application. So the login page or API endpoint. So you configure that once, and we start tracking whether the username and passwords we're seeing are stolen, like are they coming from known stolen databases, and we keep track of billions of stolen credentials. We figure out if it's a brute force attack, so if there are too many successes or too many failures for a specific session or specific IP, we flag that, we can block that. So again, everything that deals with your login process. You can use it, as with all of our rules, in enforcement mode, so basically challenge and block incoming suspicious traffic, or you can use it only to signal, to add labels or custom headers towards the application, so maybe the application can deal with these suspicious actors and maybe step up the authentication process and send out an SMS. So again, using WAF as a signaling mechanism, not necessarily only as a enforcing mechanism. And the second rule that we deal with fraud is ACFP, so I know it's a mouthful. Account creation fraud prevention, which deals with the sign-up process, not the login process. So again, you configure it once. You set the login form or the login API endpoint, the sign-up API endpoint, where users typically sign up. And we start detecting anomalies that have to do with this sign-up process. So suspicious email domains, stolen credentials, like there's a bunch of rules within those two managed rules that track all sorts of anomalies. And we keep on updating them as new threats arise. All of these three, so bot control, targeted bot control, ATP, and ACFP, are way more effective if we can actively challenge an incoming request. So I won't go through the entire flow of the challenge, but eventually a request comes in. For some reason, we choose to challenge it. We first make sure that the browser itself can really run our challenge, or you can implement our SDK into our web application. It's a very simple JavaScript SDK, and we even have mobile, so iOS, Android TV, and Apple TV SDKs you can implement into your native applications, and we can challenge those applications directly. Once we do that, we first guarantee that it is indeed at least a browser, and not just a script, or at the very least a browser that knows how to handle JavaScript and return cookies and follow redirects, which is a more expensive browser to run at scale, a bot to run at scale. And then we also gain like a session ID, like a unique fingerprint for the session, and we can start tracking that fingerprint for anomalies. So we no longer look at IP addresses, which are easily switched or can be hidden behind. And we start tracking the actual session, which is a much stronger tracking point for us. How does this all come together? Let's start speaking about mitigation techniques.
So now that we looked at all the detection capabilities, we looked at mitigations, we looked at the actions, we can start by looking at different strategies that we can use to mitigate once detected. So there's a lot in this slide, so we'll focus a little bit on the adaptive defense, but just covering this. So sophisticated attack mitigation typically evolves around all of these things. So it's not like if you do one thing, it's going to be very effective. So from a strategy standpoint, you have to look at all of this, right from zero trust architectures, how do you leverage threat intelligence, how to build incident response. In this presentation, we'll focus on adaptive defense, because that is one area that we've seen customers get really creative with how to not block these sophisticated bots, but to make sure they do not know that we have detected them. So the 4 Ds of mitigation, right? So there are really 4 ways of how you could do adaptive mitigations. There's diversion, which is like, okay, you identify that, hey, this traffic is coming from a bad agent or your attacker, and you just block those attacks. Now, this will work great with simple bots, script kiddies, curls, all of those things, but this will not work with the targeted bots, because as soon as they realize that they've been caught, they're going to change their attack vector, and they're going to bypass it. With distortion, it's a little different, where we are not now doing positive security, where we are, instead of trying to block bad stuff, we're just saying, hey, we know this is good stuff, let's just allow that through. Depletion is, if you attended the threat research talk we did on Monday, we talked a lot about how the AWS threat research team works with different partners to do takedown requests when we detect command and control servers. So that's another aspect there of depletion. For deception, this is an interesting one, because there are certain nuances in deception that can be really effective depending on your use case. So let's take a look at some of those. So here are some of the techniques that we see implemented across our customers. One is like fake success. So if we detect the bots, we do custom response. Zuri talked about we can do custom response for the HTTP code as well as the response body. So we let them think that they have not been detected, but we don't allow the request to go back to the application and then send it 200 or whatever to let them know that they're succeeding. Then on the other hand, there is fake failure, where we detect them and then we either send 429 to slow them down, or we say, okay, 301 redirect, or something else that Usually, like bot attackers, they look at the response as well, like the sophisticated ones, and then if they don't see what they expect, they will change their attack vectors and all of those things. So here the idea is not to, like, we are blocking them, but we are also wanting to confuse them to think that, okay, I didn't expect really a 405 to come in, and what do I do now? So that's the idea there with fake failures. Fake execute is really powerful because here what we are doing is we are using the labels concept as we talked about to tag certain requests and allow them to go. So for example, if you have a CloudFront distribution and you have bots or WAF attached there, you can add that custom header and then at the application load balancer or API gateway or your routing layer, you can make a determination that, hey, you know, don't send this to a real application, send it to a honeypot or a different application. A lot of customers, like we have online dating customers who do this for generating AI images. So the attackers don't really know if the image that they're scraping is a real image or a fake, right? So there's various ways, and then there's a lot of strategies that can be built around this where your threat intelligence team, your SOC team can start looking at how the attack is progressing in that honeypot environment so that you can better protect when the attack happens next time. And then we have normal execute where, okay, we let the attack through, we know that there might be some attack that goes through, and we're okay with that, right? Like we block whatever is obvious, but then the small area where there's a gray area where we really don't know, good or bad, depending on the use case, you may determine that, hey, blocking customer is more of an issue rather than blocking bots, so you may still want to allow it and you may be okay with it. So now that we understand this, let's bring it all together. We'll start with some basic architecture and go into some of the use cases. Suri, do you want to build the architecture?
Yeah, so that would be a typical architecture that we see customers use, a very simplistic one, I agree. So the very first thing we want customers, incoming requests to hit is CloudFront. There's a bunch of values in having CloudFront front your web application. It could be anything from performance, cost, security, and offloading from the backend servers. So there's a ton of sense in using CloudFront. CloudFront can route traffic to your active parts of the application through a behavior that points at an ALB. And then after that ALB would be your actual application. And it can also route traffic to your static assets like your images, CSS files, the things that are cacheable and are stored in an S3 bucket. That would be a simple, if you look at a single page application, a very simple layout for that. With WAF, you would typically want to see WAF attached at the very front to CloudFront, dealing with the brunt of the attacks, close to the attackers, especially on volumetric attacks. We do see customers use WAF on the ALB as well. If they have like a defense in depth approach, or they do certain things at the edge and other things at the ALB, maybe different teams manage different parts of the application security structure, but eventually, for the most part, we see CloudFront and WAF, and then everything goes behind it. So let's turn the theoretical that we've done so far into practical.
Yep. So I'll play the role of a customer. I'm a customer. I have a website that has sign-up rewards, that has referral bonuses. And Zuri, I'm facing this fake accounts and fake logins, and they are abusing this, right? Like they're getting those $5 bonuses that I'm offering with sign-ups, and I'm losing revenue. How can you help me?
So you need this done like in 2 weeks or so?
No, today. Though.
Not a problem. OK, cool. So basically, we're trying to aim at a scenario where we're being targeted for fraud. So it all seems like a usual login or sign-up process. And we want to make sure that we are blocking the fraudsters without having them know that we're blocking them and evolve their fraud. So that would be the end game for us. So we want to keep that like as silent as we can from that standpoint. So we start by adding the 2 fraud rules that we mentioned before. So ATP and ACFP, account takeover prevention and account creation fraud prevention. So we add them, and we add them in a way, we'll see the config in a second, but we add them in a way that won't block. So by default, a lot of the sub-rules within those managed rules are set to block. We'll set it to count. The other thing we want to do is we want to enable or add the SDK to our front ends. There are multiple benefits of using the SDK on your actual application, implementing it in your application. It's a very simple copy and paste operation into your front ends. And it makes sure that all incoming requests or all incoming sessions will immediately get challenged, and we now obtain a token on them. It doesn't block if the challenge fails. So we just know that the token is absent because we now have a label for it. And it costs less if you do it this way than you do with active challenges through the rules. So that's what you would do. So from the architecture standpoint, nothing really changes. We just added a couple of rules, and we added the SDK to the front ends. Now, once we do that, again, mentioned, we do not want to block incoming requests. That's a screenshot from ATP. ACFP is a bit longer. It has more abnormal behaviors that it deals with. But we want to make sure that the ones that are set to block initially are now set to count. What that will do is we now have a session ID, so we know to track users. We don't block on any of the offending behaviors, but we now label them. So we now have additional data we can use about suspicious behaviors. So with that, we'll create a custom rule. And remember, the order matters. So that custom rule should be right after or anywhere after ATP and ACFP that looks for the labels emitted by ATP and ACFP. When we do a label match rule, there's also a way for you to mention that you want a whole namespace of labels. So anything emitted by ATP, anything emitted by ACFP, not necessarily the specific violation. So it's a simple way to configure that. And now what would that rule do? That rule could do one of three things, basically. And it's exactly like Costa mentioned. So one would be just to count. We're just counting all of the requests that matched the ATP or ACFP behaviors. Once we match, we don't block, but we add a custom header, right? And who would read that custom header? That would be your front end, your application. So you can bake whatever business logic you want into your application, looking for those specific headers, and those headers would carry what exactly went wrong with the request. So again, using WAF as a signaling mechanism, like a downstream signaling mechanism, and do whatever you want to do with it on your fraud solution. Secondly, you can fake succeed, right? You can turn a 200 OK, welcome user X, here's your $10 coupon, knock yourself out. So a fake success will make it more difficult for the fraudsters to understand that they've been blocked. Plus, once we know that, we can start distributing like a fake coupon number and start tracking if that coupon is being used, and so we know like to close the circle when it gets abused. So the fraud is only the first part, right? Using the coupon is the thing that we pay for. And lastly, we can do rerouting. So again, like the first scenario, we only count, and we add a custom header, and any underlying service right behind CloudFront and WAF can deal with that custom header. So it could be a CloudFront function that rewrites the origin, or a Lambda at edge function that reads the header and rewrites the origin to be a honeypot, or maybe a more secure application, or maybe something else. It could be an ALB rule, right? So we can use that custom header to route traffic differently in a way that allows us to track what was done while letting the fraudster feel like they've succeeded in their attempt.
Awesome. So now that the fake accounts and fake logins have now been resolved, great, I have more revenue, I want to get real customers now. Let's go and do a marketing campaign. So we have a marketing team that is running a marketing campaign. They're launching mostly static assets.
Wait, is it launching or already launched? I have a hunch it's already up there.
Yeah, it launched yesterday.
Okay, cool, no problem.
Then we have the static assets. We don't really care about the complexity of the website. I just want the website to be available for the duration of the campaign, and that's it. So availability is more key.
Okay,
Can you help me?
So you don't really mind if some script kiddies try something because there's nothing to abuse.
Abuse, yeah.
It's mostly availability. Got it. And you're saying like we're already in production, so that's very timely. Cool, thanks for that. So I wanna have a configuration that will allow me to tighten security or become more aggressive when some suspicious behavior starts happening. So basically a configuration that does nothing or close to nothing until something happens. So we'll start by adding a rate-based rule. Promised you we'll use rate-based rules. So I will use a rate-based rule, which is not scoped down to look at any kind of traffic pattern. Just counts all of the requests. Maybe I can count all requests except for the request coming from my QA tools or whatever. I can maybe scope down some of the requests, but basically counting all of the incoming requests towards that application. This rule is not set to block. It's only set to count. So it's a rate-based rule that only waits for a certain threshold, which is for you, it might be 5,000 requests in 5 minutes, could be 1 million, could be 10 million, whatever the number is for you to be considered suspicious. And once it does that, it starts emitting labels for all of the requests that went beyond the millionth one in the last minute. Again, the number may change for you. So basically now we have a rule that waits for a certain surge in traffic. It's all a WAF configuration, right? You can do it also with CloudWatch metering and automations and a Lambda function that changes configuration, but it's way simpler to just add a rule that emits a label for all requests that went over a certain number, not from a specific IP address, not from a specific country, all requests. Now, what will we do with that label? Let's say this label will be called volumetric traffic for the ease of understanding. So once we start seeing requests that carry the volumetric traffic label, we can know that something fishy is going on. So we pre-configure another rate-based rule. Remember, we said we should have at least 3 rate-based rules in your policy? That's a good example why you should have at least 2. So we have a secondary rate-based rules that rate limits IP addresses to a certain amount of requests. Because it's a mini site, I would say 200 requests from an IP address within a minute is plenty. So let's set it at 200 requests from an IP address, but we only look at requests that were labeled with the volumetric traffic label. So this means that normally this rule isn't doing anything. So someone can send 1,000 requests without getting blocked because we don't care. It's not enough to cause me any damage. But once overall traffic went over a certain point, this rule starts getting enforced. So noisy IP addresses will get rate limited, and normal IP addresses will keep on using the minisite, no issue. So these are 2 rate limiting rules. One is enabling the other. We can also use the label to start enforcing IP reputation. So normally, Kostab told me that we don't care about bad IPs. But if they jeopardize my availability, I want to start enforcing my IP reputation managed rule for traffic that was labeled with volumetric traffic. So only when we go over a certain threshold. So this will allow me to automatically tune up my security posture in case of an emergency. So that rate limiting rule would look something like this. It's super simple. So it's a rate-based rule that only inspects requests that has a label, in this case, volumetric traffic. Lastly, we can also use bot control because bot control has a separate cost. We don't want to have an expensive solution that runs unnecessarily. So we can have bot control be scoped down only for when these attacks or these attempts at a volumetric flood on my application are happening. In all other circumstances, we don't even use it. So bot control enabled, but only looks at traffic that was labeled with the volumetric label, volumetric traffic label. Will that be enough?
Yeah, for now. Now that I have my fraud under control, I have my marketing, I have new users, now I'm more confident. Now I want to use WAF for protecting my real application, or that is revenue generating application. Now this is a little bit more complicated where we have not just static content, there are dynamic APIs, there are different types of devices that are going to be accessing, like browsers, mobile devices, etc. And I want to have different controls for different types of traffic in the most cost optimal way.
Got it. Okay, not a problem. So we'll start our ACL in a way that only allows us to start marking down traffic. So we'll have a bunch of count rules, a bunch of rules that don't enforce anything, but all they do is match certain criteria and label them. So it could be something as simple as label all traffic from our trusted IP addresses, our partners, our testers, whatever. Only label that, and we'll use that label afterwards. It could be managed rules. So I want to enforce SQL injection, so I do enable the SQL managed rule, but I don't have a good appetite for false positives. And not all parts of my application are susceptible to SQL injection. So I want to avoid false positives. So I enable this rule, but I don't enforce it. I switch it to count, and I trust that it will emit labels once we match on SQL injection attempts. It could be suspicious countries, it could be specific URIs, like if you have a very heavy, computationally heavy URI, maybe it's your search page, or maybe it's a download mechanism that forces a lot of traffic out. All of the sensitive URIs, you can flag them with a match criteria rule that only counts and labels. So we'll have a bunch of these count and label rules. And now, when traffic starts being sent through the WebACL, we'll collect all sorts of labels about that specific traffic pattern. So we can start saying, OK, this is a request that was flagged with a SQL injection, but it targets an S3 bucket. So, OK. It doesn't flag the sensitive URI label. On another occasion, we can say this request carried a cross-site scripting attack, and it targeted my login API endpoint, which is more dangerous. So we now know more about each request. And then we can start driving a risk-based configuration in our WebACL and start creating rules that look at those labels. Before we do that, we can also look at bot control. Again, this is a rule that has a separate cost, and we can run it in common mode, which is cheaper. And again, looking for naive bots, but most importantly, it flags our verified bots. So again, running common bot control in count enriches incoming requests with known verified bot labels. So now we know if traffic is coming from verified bots, and maybe the later rules, the one that do enforce blocking actions on traffic, we want to exclude our verified bots from. And we can also use targeted bot control on other parts of the application. So this is the more expensive mode, and we only want to use it on specifically labeled types of traffic. Now, it's not, I specifically used that slide here because it's not very trivial through the UI to add 2 versions of bot control to your WebACL, because the UI will only allow you to do it once. But all other methods of managing WAF, CLI, SDK, our CDK, SDK, Terraform templates, API calls directly, they all allow for multiple versions of bot control to be added to the WebACL. So we can have bot control scoped down to specifically labeled requests. So we only use bot control for our login, or not login, let's say search URI. And then we end up the WebACL, so the bottom part of the WebACL will be chock full of rules that do enforce, do block, do challenge incoming requests, but only if they were labeled accordingly. So as mentioned before, let's use the SQL injection example. We had a bunch of rules early on that looked for multiple things. So we now see a request that carries a SQL injection pattern in it. So we look at the labels and we say, OK, it has a SQL injection label because our managed rule labeled it. It has the sensitive URI label because our sensitive URI rule managed it. And it does not carry the trusted IP label. This is when I start blocking SQL injections. So I very surgically choose when to enforce rules limiting or diminishing the risk of having a false positive. I will only enable these rules when it's important to me. This will allow me to protect different parts of the application differently. It will allow me to enforce a different security policy on higher risk sources, such as bad IP reputation, suspicious countries. And I can have all of the enforcement rules look for the labels that were previously emitted by the top-level configuration.
Awesome. That's great. So with that, we have a few resources that we would like to recommend. This includes like a bot mitigation strategy. It talks about all the things that you should consider when you're starting to build a bot mitigation strategy. There are some configuration examples. Zuri went over the challenge flow. There's a more detailed version of that as well. So again, something if you're interested to read more. We will hang around here for a few questions. We really want to thank you for your time. We have our LinkedIn up there if you want to connect. And please, if you can fill the survey, that will help us as well. So thank you so much for all your time, and have a good rest of your day.